This is fundamental problem 8 from chapter 13. We want to determine the maximum speed that the Jeep can travel over the crest of the hill and not lose contact with the road. We have the radius of curvature given to us, so the car is not driving in a full circle like this, but at this point you can model the road going over the hill as part of a circle with a radius of 200 feet. So the first thing that we should do is identify the normal and tangential direction. So the tangential direction is easy because that's the direction that the object is going in. So tangent to the path of the Jeep would be like this, and the normal direction is pointing in towards the center of the circle. So after identifying the normal and tangential directions, I want to draw a free body diagram, and that's the Jeep. I should have just made it a dot, but the size and shape of the object, fortunately, don't matter. Okay, so I have my tangential direction and my normal direction. I guess we'll put some wheels on it. Okay, so pointing down, we have the force of gravity, which is the mass of the Jeep times g, and the hill is touching the Jeep and exerts a normal force upwards. There are no other forces acting on the object. These forces act in the normal direction, and I know the sum of the forces in the normal direction is equal to the mass times the acceleration in the normal direction. And I know the acceleration in the normal direction is v squared over rho, so I want to use these two equations together to say the sum of the forces in the normal direction is equal to the mass times v squared over rho. The sum of the forces in the normal direction, remember that the positive direction is pointing inwards towards the center of the circle, so mg is positive and n is negative because mg is pointing in towards the center of the circle. This is a little different than what you may have done in Physics 161, because in Physics 161, outward probably would have been the positive direction, but then the acceleration here would be negative, so it works the same just with opposite signs. So this is mv squared over rho. Well, now we need a little bit more information. So if we go back and read the problem, it says we want to go as fast as we can without losing contact with the road. The faster you go, the smaller the normal force is, and if you just lose contact with the road, the normal force would be 0. So at max speed, the normal force is 0. So that means we have mg is equal to mv squared over rho. The mass cancels out, which is good because they didn't give us a value for the mass, and we are looking for the maximum speed. So if we multiply both sides by rho and then take the square root, we have v is equal to the square root of g times rho, which result you may remember from Physics 161. So if you're going as fast as you can, that speed is equal to the square root of g times the radius. Okay, and we have the radius given to us, that's 250 feet, which means for g we want to use 32.2 feet per second squared. And that gives us the square root of 8,050 feet squared per second squared, which is 89.7 feet per second. And that is the answer for problem 8.